Hello. Going to talk a little bit about a theory of everything. Oh boy. Scientists have been looking around, I guess, ever since they discovered the atom and then subatomic particles and galaxies and all of that stuff. They've been trying to put together a theory that explains it all. And basically, their theory of everything never includes life, which I found very interesting. It's the theory of everything that includes everything but life. I find that kind of fascinating, how they could call it a theory of everything without including life. So anyway, what they've come up with in the I guess it was back in the 40s, a guy named Lemaitre, who was a priest, since the Hubble telescope had showed that the universe was expanding, he thought, well, gee, if it's expanding, I wonder if it's expanding from a point. So he came up with a theory called the Big Bang, where everything originated from a point in a big explosion kind of thing. And about the same time he did that, a guy named Friedman came up with the same idea. So you had around the same time the Friedman universe that started from a Big Bang and Lemaitre's universe starting from a Big Bang. The Pope, Lemaitre's Pope, was so excited that he said, "That's God there at the point of that Big Bang. You've discovered God." And of course, the scientific community didn't really like that. And so they started off really not liking the Big Bang theory because scientists did not want to include the idea of a creator for which there's no evidence in the theory of the Big Bang. And that still is the case today, that even though there are 6 strong evidences of the Big Bang theory, the main one being the discovery of the cosmic microwave background back in the late 60s, which was really the remnants of a fireball that existed with the center that was 380,000 years after the point of the Big Bang. And they were able to take better and better pictures of the remnants of this fireball, which were microwaves, and it was spherical. And so since it was spherical, that means there's a point at the center. And that was the first big proof of the Big Bang theory. Since then, there have been other proofs of the Big Bang theory. Now, what these scientists did, they said, well, okay, there's a sphere, and I guess the universe is an open sphere expanding from a point. And then they said, well, okay, we'll look at this sphere and we'll find the center and draw a line from the center all the way out to where we are and beyond, and then we will locate events along that line and call it time. Now, what I find interesting about that is that, in a sense, we created that line from the center all the way out to the limits of where we can observe. But if you just look at the sphere in and of itself, there is no line going from the center point out to where we are and beyond. If you look at the sphere, you have all of the things that happened along that timeline that we created, like when atoms form, then you have the cosmic microwave background, then you have stars forming, and you have then galaxies forming, and then island galaxies forming. If you look at if you were able to step back, like outside of the universe, which of course is impossible, and look at the sphere, you would see, oh, well, there's a sphere, and there's all that stuff, all the galaxies and everything, and right at the point at the center, it seemed like there was a fireball, and then all these other things happened. The story that the scientists were able to make up was that, well, you have this hot fireball, things start cooling down, and eventually condensing into stars, stars gathering into galaxies and all of that. The problem is that they've never been able to find the point of the Big Bang. They have gotten within 10 to the minus 46 seconds of that point, but they just can't find the point. And because they can't find the point, and because a lot of them didn't like the Big Bang Theory, they say, well, since we haven't found the point, we can't really say that the entire universe came from a point. For me, 10 to the minus 46 seconds is pretty damn close to a point. But the reason they can't find the point is because a point isn't a thing. So they can look forever for a point. You can't find any points. So a point is more like an idea. And they would always ask a question, the ones who didn't like the Big Bang Theory. Well, it couldn't come from nothing, which is what the Big Bang Theory says. All of the stuff that we could possibly think of or know came from a point or nothing. A point is not a thing. I said, well, that just can't be, because we don't see things arising from nothing. So we're not going to really accept this Big Bang Theory. And besides that, we don't like the idea of, although they don't talk about that, of associating a creator with that point. So another problem that they invented regarding the Big Bang Theory was that when they measured the temperature of the universe associated with the cosmic microwave background, they found that the temperature was the same in every direction. And they thought, now how in the world can that be, that the temperature is the same throughout the universe associated with the cosmic microwave background? Because if you start from a point and you have everything exploding from that point and exploding so fast, that means something that goes off in one direction and the opposite direction would not have a chance to communicate with each other about the temperature being the same throughout the cosmos. So they thought that was a big problem. And so this one guy named Alan Guth, a physicist, invented, we're scratching our nose today, invented a solution, he thought, to this problem. And he said, well, what happened was there was something called inflation, where the quantum vacuum expanded at a huge rate over a matter of less than 1 second, and when since it was a quantum vacuum, everything was in connection at the time of that big expansion, and then it slowed down. The expansion slowed down and kept slowing down so that it could form atoms and molecules and stars and all of that kind of stuff. Well, that's a story, and that story has become the story of the Big Bang inflation, and that's the dominant story of where all of this stuff supposedly came from at the beginning of the universe. In fact, once they introduced this inflation idea, we're scratching our nose today. Once they introduced that inflation idea, they started playing around a little bit more, and they said, well, maybe we can just get rid of this Big Bang theory as really our universe and the beginning of our universe, and say instead, well, you know, how do we know that that's the only Big Bang? because it's quite possible that there are endless other Big Bangs bubbling up out of the quantum vacuum. Of course, there's no evidence for that, but by saying that, they were able to get rid of the idea that possibly a creator might have, or all of this stuff came from nothing, and they were able to do marketing against the 3 mm Big Bang theory, and that is becoming the dominant theory nowadays. Is, well, there were endless Big Bangs, and there's this multiverse of endless bubbles coming up out of the quantum vacuum, creating endless universes, for which there is no evidence. Contrasting the Big Bang theory, where there is lots of evidence. They have been marketing heavily against this Big Bang theory. Now, if you look at the universe as a sphere, and you say, well, there's no real evidence for the inflation model of the Big Bang theory, although they have a lot of experiments that they've done that support that theory. However, these same experiments would promote the Friedman-Lemaitre Big Bang theory without inflation if you say that at the point of the Big Bang, the quantum vacuum came into existence at the same time. Now, there's evidence for that. The quantum vacuum existed 10 to the minus 46 seconds after the point of the Big Bang. So why not just, you could assume, if we're going to make up stories rather than the inflation story, we could say, well, the cosmic microwave background existed at the point of the Big Bang, where everything came from that point. Well, in that case, everything would have been in communication with everything else, because the quantum vacuum, which I haven't talked about yet, because I haven't talked about the standard model of particle physics, but the standard model of particle physics goes along with this Big Bang theory, and it says basically that 4% of the universe is atoms. 26% is something they call dark matter, and they don't know what that is, but it seems to hold galaxies together, and it seems to be kind of like gravity, holding galaxies together and Allen galaxies together. And then the rest of the universe, 70-something%, is the quantum vacuum. And the quantum vacuum is energy, and it creates all things. So all the atoms, which is 4% of the universe, consist of subatomic particles, which are waving in and out of the quantum vacuum. They appear and disappear. It's kind of like in the old days, the old-time televisions, when you weren't really connected to a station, you would see this psss, a sound like that, psss, and you see all these dots appearing and disappearing real fast, and that was subatomic particles are waving in and out of the quantum vacuum. So they discovered 12 years ago, 9 years ago, the reason they built that big expensive CERN collider in Switzerland, they were looking for what makes the subatomic particles, what gives them mass. And so they spent $1 billion to construct this 17-mile circular particle collider, where they were looking for what they call the God particle, or the Higgs boson, named after Peter Higgs, who postulated that there must be a particle that exists that gives all the other subatomic particles mass. They found the Higgs boson, the God particle, and they stopped calling it the God particle at that point. And so what they know now in the Standard Model is that mass comes from energy moving through the Higgs boson field, creating mass of subatomic particles. And they kind of compare that Higgs field to molasses. Isn't that cute? The energy gets stuck and becomes particles. So basically, the Standard Model, that's the basic story of the Standard Model. And fitting that into the Big Bang Theory, you have the quantum vacuum appearing at the point of the Big Bang. So the point of the Big Bang and the quantum vacuum are beyond time and space. There is no time or no space at that point. Well, so then we have, if the quantum vacuum is beyond time and space, and the quantum vacuum creates all things, then how can you imagine or conceive of these trees, you and I, and all of the supposedly solid things we see? How can we say that it comes from an energy field that is beyond time and space? That's a mystery. So all of these solid things that we see around us, that we play with, that we use to create the world that we live in, are really mostly quantum vacuum. Only 4% of everything that we see is atoms, which is kind of hard to get a brain around. Or if you say, take the idea of water flowing down a stream. All right, you're telling me then that the subatomic particles that make the atoms, that make the molecules of the water flowing down that stream, are constantly waving in and out of existence to form the atoms that form the molecules of the water flowing down that stream. Well, that's hard for me to get a brain around. If I look at the stream flowing and I ask, where is the quantum vacuum in relationship to that stream, or in relationship to trees, or my body, or your body? Where's the vacuum? Well, it's pretty hard to get a brain around that. If you break down the stream, or you or I, and say go to the molecules, and then go to the atoms, and then go to the subatomic particles, oh, they're waving in and out of the quantum vacuum while they're in that stream, or while they're in you and I. So the quantum vacuum creates all things, moment to moment, thousands of times a second. We're being recreated. Phew, boy, oh boy. So this theory of everything that I'm presenting here is not the same as the standard accepted and marketed world of the Big Bang Theory with inflation at all. And it is saying that all of this came from a point which is not a thing. Now, if you ask, let's see, it came from a point which isn't a thing. We draw a timeline out from that point all the way out to the expanding universe as it's moving along. So these people that don't like the Big Bang Theory, they say, well, what came before that point? Now, that question is a marketing question that they're using because they don't like the Friedman-Lemaitre Big Bang Theory. They want to get rid of that. So asking the question, what came before the Big Bang, is the same as asking a question, what comes before the center of a sphere? Duh. That question is nonsensical. It's like asking, what's the marriage status of a nickel? It makes no sense. So this endless marketing against the Big Bang Theory is kind of I've noticed it happening for like the last 10 or more years, and I find it very there was a little earthquake there that happened, folks. So anyway, we have from my point of view anyway, and I think there's some other folks that have a similar point of view nowadays. They're really criticizing this inflation theory. In fact, one guy who was behind putting the Big Bang Theory together, I think his name is Steinmart, Paul Steinmart, I think is his name. He's come out with a new theory that he calls the Big Bounce, which is that, first of all, he says inflation's all wrong. Everything came from that point, which is nothing, from nothing, and it expands out, and then it finally gets tired of expanding, and then suddenly contracts back to that point, and then bounces back out into another Big Bang. Well, it's a cute idea, but there's no evidence for that big bounce or the collapse of the whole universe back to that point. It's just a cute little idea, I guess. So basically, I guess what I've just presented is kind of a theory of everything, except that it's not really talking about how these things happen. How does the energy of the quantum vacuum move through the Higgs field to become subatomic particles? How do the subatomic particles become atoms? And then how do the atoms become molecules? And after they become molecules, how do they emerge into other things like trees, stars, whatever? That's called emergence. And science does not know how emergence happens at all. But they're trying to get there. And they're using cellular automata, which I had never heard of until a few months ago, to try to explain this emergence from one level to another. And it turns out the cellular automata are fractals, and that you can see it happening in nature. And so there are these simple rules of how something, say a subatomic particle, could possibly become a certain kind of atom. And there's some rules of how that atom can become a molecule, but we don't know what the rules are. So they are now deeply into diving into cellular automata to try to figure out how this emergence occurs. Now, regarding this theory of everything, and regarding this emergence from the point to our whole universe, I have a good time with a lot of so-called materialists and religious people in talking about how that point of the Big Bang represents all potentiality. So it even represents anything that we could possibly observe or do or whatever. The potential of all is represented in that point. So that would include the potential of you and I and mosquitoes and living things, all of which display consciousness, if you describe consciousness as relating to the surround on a spontaneous level. That would mean then that the point of the Big Bang is the potential of consciousness. The potential of persona has to be associated with that point. Now, some people would then say, oh, you're then saying that God is at that point, at the center. No, I'm not saying that. I'm saying that it's the potential of persona, the potential of consciousness, and you can't pray to the potential of God. And with that, I'm going to, I'm not really sure how much time this tape has before I continue on with the life part of the theory of everything.
It's been 25 minutes.
So my good friend Caleb is operating this to me fancy looking camera, but it's probably kind of crude, just like this whole setup, which is fine with me because I like crude stuff. So anyway, what's the time limit on these things?
It can keep going for a while, probably like an hour. I'm not entirely sure. It depends on the battery more than anything.
Oh, on the battery.
Yeah.
Okay. Well, in that case, since we got interrupted on the first video I made when the battery ran out, I'm going to sign off here and come back with the life part of the theory of everything. So I'll see you in the next one.